Welcome to the ENME 351 video lecture series. This is part one of a three-part installment on sensor errors and calibration. This lesson focuses on the concept of measurement. Measurement is really at the heart of all mechatronic systems. For a mechatronic system to take action in its environment, it needs to understand the state in which its environment is operating. The first step in any measurement is going to require a determination of the objectives and a measurement of key variables. So first sub-question then would be, what question are you attempting to answer with this measurement? A second sub-question is, well, what needs to be measured in order to answer those questions? And then a third sub-question would be, well, what variables are going to affect these results? It's important to note here, there are several different types of variables that you'll have to deal with when taking a measurement. The first type would be independent variables. These variables can be changed without affecting other variables. Dependent variables, these will affect other variables. And a third type will be extraneous variables. Extraneous variables are variables that are not or cannot be controlled during the measurement, such as, say, the weather. A second subset of questions that we'll need to answer anytime we're taking a measurement is in regards to the system and the tolerance design. Questions in this subset might include, well, how do we perform the measurement? And in terms of tolerance, well, how good does the result need to be? The final subset of questions are going to revolve around the data that we actually collect with our measurements. This subset will ask the questions, how do we interpret the results and how good is the answer, as well as, well, does the answer make sense? Right? So this is often one of the most important questions. If we take a step back and look at the data, does the answer, does our conclusions actually make sense? With these questions in mind, let's take a look at a quick example regarding gas mileage. Here the governing question is, what is the gas mileage in my car? In order to answer that question, I need to determine, well, what needs to be measured? In this case, I'm attempting to measure gas mileage, so I'll need to have some idea of the fuel that I've consumed with regards to the distance that I've traveled while consuming that fuel. And thus, I need to measure the fuel consumed and the distance traveled. Now, if I think about the variables that can affect my results, this has the potential to be a rather long list. So here's a few of the perhaps more pertinent variables. The type of fuel that I'm using, the driving that I'm doing, if I'm in the city or if I'm in the highway, just chugging along the miles. The road surface that I'm driving on, was it recently paved? Is it a dirt road? The tire pressure in the tires in my car. The car type, is it a sports car? Is it a SUV? The speed at which I'm driving, the driving style, maybe I have a lead foot. The weather, is there a significant headwind? Is it raining out? Right, the list of the variables that can affect these results is rather extensive. If I think about the type of variables that these might be, the type of fuel, that'll be an independent variable. The road surface, that'll be a dependent variable since other things are going to be affected by the road surface. And then the weather, that'll be an extraneous variable since it's out of my control. Another governing question we'll need to answer is, well, how can I perform these measurements? Well, in terms of the distance traveled, if we look at the distance or the miles traveled, we could use several things to perform this measurement. We could look at GPS, we could look at our odometer, we could look at the average speed and the time, maybe using a stopwatch. So there's several methods in which we could perform that measurement. And in terms of measuring the fuel consumed, I might be able to measure the mass or the fuel rate over time or the volume of fuel that was consumed, right? So there's several different ways I could quantify the fuel consumed as well as the miles traveled. Now, if we think about the tolerance design of the system, we need to consider, well, how good do the results need to be in order to appropriately answer, well, what is the gas mileage in my car? Obviously, this question and the associated answer will help drive the type of sensors that I'm going to use for this measurement. For example, if I need to measure the miles traveled very precisely down to millimeters, well, GPS won't cut it. So how good do the results need to be? Well, if this is just for curiosity, maybe we're having a coffee and talking about it, perhaps plus or minus 1 mile per gallon is sufficient. If I'm performing this measurement for, say, the CAFE standards, the corporate average fuel economy standards, I'm going to need to get that down to plus or minus 0.1 miles per gallon. So the takeaway here is, depending on what you're taking that measurement for, what you're trying to accomplish, how good the results need to be, that's going to drive the design of your sensor system and the associated hardware, the associated sensors that you use to take those measurements. With regards to the concerns of the quality of our data, often we want to replicate or repeat our measurements. Replication, that's going to be a duplication of measurements under the same operating conditions. In contrast then, repetition, that'll be repeating measurements during the same test. So for example, this might include measuring the mass of fuel in a car while the car is standing still. So these, along with any noise or any extraneous variables that present themselves during our measurements, they're going to answer the question, how good is the data? Although replication and repetition help us answer this question, also consider the fact that replicating measurements and repeating measurements often requires time and money. So there's usually a happy medium between this concept of replication and repetition, and in the real world, meeting schedules and budgets and timeframes and so forth. So there's always a bit of a balance with regards to optimizing replication and repetition for your particular measurements. With regards to the question, does our measured value actually make sense, we're going to use concomitant methods. So a concomitant method is simply using a different technique to achieve or perform the same measurement. And once again, these methods are used simply to answer the question, does the measurement make sense? So if we go back to our gas mileage example, concomitant methods in terms of, let's say, miles traveled, they might be using a GPS or the average speed and time with a stopwatch to measure the distance traveled, right? Those would be concomitant methods where we're using a different technique for the same measurement.